So now we have the second video about reactions in aqueous solutions where we're going to introduce here precipitation reactions. So when you mix two solutions, so ions that are generally soluble, what happens is a precipitate can form when ions from two different solutions mix. So this insoluble compound, this is what we're going to refer to as a precipitate. And we can predict when a solid would form using some solubility guidelines that will be introduced below. So in general, this terminology, a precipitate, is the insoluble solid that is formed by a reaction. And in the next video, we'll talk about specifically these double displacement or sometimes called double replacement reactions. And that's what we see happening over here. So we had clear solution here, but when they're mixed together, we see this yellow precipitate forming. And if you watch the video that is linked below, this specific reaction, we would see potassium iodide. So we'll call that aqueous potassium iodide. We need, in the balanced reaction, 2 moles of that to react with lead nitrate here. So we have PbNO3 also aqueous. And then what happens over here is that we're going to form a precipitate here, which is going to be lead 2 iodide. So PbI2, that would be our solid. And then we'll have just aqueous potassium nitrate. So how I've written this is the molecular form. Because in the ionic reaction, which we'll see the difference in a subsequent video, I would break down 2Ki and then 2NO3 negative. So again, this wouldn't be written as well, but this is the molecular form of the reaction that you would see here and in this video. So how can we predict if a solid forms? We can utilize this table here. And I'll introduce how to read this table. So we have soluble ionic compounds listed. So these would all be salts. So once they're dissolved in water as the solvent, we would get ions. So specifically, say we have potassium nitrate like above, all compounds containing nitrates will be soluble. And over here, we report any exceptions to this rule. And with nitrates and this second row here, acetates, there are no exceptions. So we can say that anything containing nitrate or the second here, this acetate, will be soluble all the time. So any salts with those. But we have some exceptions for chlorides, bromides, iodides, and sulfates. So these first three, the exceptions are the same. So any silver containing, mercury 2 containing, or lead 2 containing compounds, when they, aqueous solutions rather, when they mixed with chloride, bromide, or iodide containing compounds, they're going to form a solid, a precipitate. So that's how we can look at these important exceptions and say, okay, well, when silver comes in contact with chloride, I'm going to get this precipitate, this solid. But all other chlorides, like potassium chloride, sodium chloride, these will be soluble in aqueous solution. Then we see our exceptions for sulfates. So generally sulfates will be soluble, except for when we mix with strontium, barium, mercury, or lead. So for example, say we had lead sulfates, that would be a solid. That would form a precipitate. Then we have down in our second half of this table, so below, these are generally insoluble compounds. So anything with sulfite. So we have S2 negative. Any compounds that contain S2 negative, carbonate, phosphate, or hydroxide would generally be solids, except for when we have these ions paired with them. So in general, when we talk about these double displacement reactions happening, we can see these combinations of what are generally soluble solutions, when they're combined, they can form insoluble compounds. So let's say we have a cobalt containing ion and it's mixed with a hydroxide containing solution. We would say that in general, they would form insoluble or precipitates, except for when they're mixed with ammonia. The group 1 metal cation. So again, that's the alkali metals. So K plus, Na plus, they would form soluble solutions, or calcium, strontium, and barium. But since cobalt is not on that list, we're going to say that it's probably an insoluble compound. So that's what we're going to indicate as our answer, either soluble or insoluble. So let's go up to our list, and if I have nitrates, there are no exceptions. So barium nitrate would be a soluble compound. Then I have my phosphates down here. Anything with ammonium that mixes would also form a soluble exception to the phosphate rule. I have sodium carbonate. So sodium is an alkali metal. So I'm going to say that this is also soluble. Answer D. And then when I get to E here, I have lead sulfate. So all my sulfates are going to be soluble unless they're paired with lead over here. So I'm going to add to that this is an insoluble precipitate that forms. And then in my next column here, I mentioned all acetates will be soluble, so we'll say that there. I used when silver comes in contact with chloride ions as an example above, so we know that that will be an insoluble precipitate. And then potassium iodide. So potassium, just like sodium, chlorides would be soluble, so too would iodides here. So that's not one of the exceptions that forms a solid, so I'm going to say this is soluble. Sodium hydroxide, that's one of the alkali metals that is going to be an exception. So that will also be soluble here on our list. And when we review the strong bases and strong acids, we'll see that sodium hydroxide is classified as a strong base. And then last but not least here, I have another sulfate, but the ion that pairs with it, magnesium, is not listed on the insoluble list up above. So only strontium, barium, mercury, and lead sulfates would form insoluble precipitates. So our last answer here, J, would also be soluble. So we'll continue with more about these double displacement reactions in the next video.